Hello everyone and welcome to another Add Maths tutorial video. Now I'll be discussing SPM 2019 Add Maths past year paper, paper 2, long question, example 4 or also known as question number 4. Alright, let me read the question now. Diagram 2 shows the curve y equals to 4x minus x square and tangent to the curve at point Q passes point P. For the question part A, show that h is equals to 3, and for the question part B, the question asks to calculate the area of the shaded region. So this is the overall question for guys. So I hope you will attempt this question in the future. If you could manage to solve this question, well done. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Okay, without further delay, let me start to discuss the solution for the question 4 now. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let me start to discuss the question 4 now. Okay, for the question 4 part A, the question asks to show that the h is equals to 3. Okay, let me start the discussion now. So in the question, given that the y is equals to 4x minus x square, and then they also mentioned that the tangent to the curve at point Q passes point P. Okay, since there is a tangent forming in this equation y, so what we're going to do, we're going to differentiate this equation. So from here you should get your dy dx is equals to 4 minus 2x. Okay, let me proceed to the next step now. So since your dy dx is also equals to gradient of tangent to the curve, okay, so when x is equals to h, so you need to find in terms of y and then in terms of dy dx. Okay, why I'm doing these two values, so please hold on guys, stay with me. I'm going to give the explanation in the later of this video. Okay. So when x is equals to h, y is equals to 4h minus with h square. So from here you should get your y is equals to 4h minus h square. So this y in terms of h guys. Okay, so next we need to find dy dx in terms of h. So dy dx is equals to 4 minus 2h. So this will be your answer. So please don't get confused between y and dy dx guys, they are not the same. Okay, y is actually the equation of the curve, dy dx is actually gradient of tangent to the curve. Okay, they are both different. So from here what we're going to do, okay, this dy dx we're going to compare with the gradient of the straight line PQ. Since PQ is forming a straight line, and then this PQ is also actually dy dx. Okay, so we're going to correlate these two concepts together. So how I'm going to do that? Okay, please hold on, I'm going to explain to you now. So as you know that to find the gradient of the straight line, we need to use this formula, m is equals to y2 minus y1 divided with x2 minus x1. So if you take the look in the question here, they already give us the coordinate p over here where you have 2, 5, but then we have a problem, we don't know exactly the coordinate q. But then the question already gave us the hint by giving the x coordinate of the q where your x is equals to h. So from here what I did is, so I substitute this h value into the y equation. So when x is equals to h, so that's how I get this y value guys. So this y is equals to 4h minus h square. So indirectly your coordinate of q will be h and 4h minus h square. So these are the respective coordinates guys. So what I'm going to do is, I'm going to use this p and q to find the gradient of the straight line, and then I'm going to compare with dy dx. Excuse me. So I hope you can understand the concept, but if you still can't understand, no worries, I'm going to show you the working now. Okay, so 4 minus 2h, so where I get this 4 minus 2h, I get from here guys, dy dx, which I've already done just now. So 4 minus 2h is equals to 5 minus, in a bracket, 4h minus h square, close bracket, divide with 2 minus h. So as you can see here, this is the coordinate of the p and this is the coordinate of the q. So minus this both and you get the gradient of the straight line, where is also equals to dy dx. So from here you can perform the normal algebraic expression, guys. Okay, let us continue. So 4 minus 2h, you times with 2 minus h is equals to 5 minus 4h plus h square. So you expand this bracket. So from here you should get 8 minus 8h plus 2h square is equals to 5 minus 4h plus h square. Okay, as you can see, we have already forming a quadratic equation. So let's solve this equation. So from here you should get h square minus 4h plus 3 is equals to 0. Okay, you perform the factorization. So what you do, you factorize this quadratic equation. So from here you should get h minus 3 and h minus 1 is equal to 0. Okay, so therefore you should get your h is equal to 3. Okay, and your h cannot be equals to 1, guys. Okay, actually there is a typo over here. It should not be negative 1, it should be 1 over here. Okay. Okay, why your h cannot be equals to 1? So back to the question again. So your h coordinate is surpassing the 2 over here, guys, if you look at the question. So it makes sense, your h cannot be less than 2, your h must be more than 2. So that's how you get this value, guys. H is equal to 3. So from here we have already successfully shown that our h is equal to 3. Okay, let me proceed to the question part B, where the question asks you to calculate the area of the shaded region. Okay, for the question part B, the question asks us to calculate the area of the shaded region. Okay, let me start to discuss now. So to find the area of the shaded region, so in this case what we're going to do is, so we're going to use the area of trapezium and then we're going to minus with the area under the graph. So that's how you're going to find the area of the shaded region, guys. Okay, so how are we going to find the area of trapezium? Okay, let me show you now. So since your h is equals to 3, so when x is equals to 3, so what you do, you substitute back into the equation. When h is equals to 3, so your y is equals to 4 times with 3 minus with 3 square. So from here you should get your y is equals to 3. Okay, so let us continue. So in this case, so this is your formula of your area of the trapezium, guys. So half times with a plus b and then you times with the height over here. So 1 over 2. Okay, you look at the question over here. Okay, you plus with 3 and then you plus with 5 over here. And this one, how you get here, guys? So since your h is equals to 3, and then what you do, this 3 you minus with 2, guys. So 3 minus 2, so that's how you get this 1 over here. Okay, so this is the area of trapezium. Okay, for the area under the graph, so what you're going to do, we're going to perform the normal integration calculation, guys. So for x minus with x square with the respect of limit 3 to 2, guys. So this 3 is your upper limit and this 2 is your lower limit. Okay, and with respect to dx. So we're going to do these two calculations simultaneously. Okay, let us continue. So from here you get your area of trapezium is 4. So 4 you minus with the area under the graph. So area under the graph, so you perform the integration. So from here you get 2x square minus x cube over 3. So in the respect of the upper limit 3 and the lower limit 2. So what you do, you substitute these two values respectively. Okay, and then you show them separate calculation. Okay, 4 minus with, in a big square bracket, 2 times with 3 square minus with 3 cube over 3 minus with 2 times with 2 square minus with 2 cube over 3. Okay, so like I said, guys, in the integration, so this limit you need to substitute them and then you get a value and then you minus with the lower limit and then you substitute into this equation. So you get that value, so you minus them together. Okay, so you minus these two value, you should get 11 over 3, guys. Okay, once you get this 11 over 3, so what you do, you minus with 11 over 3. So from here you should get your area of shaded region is equals to 1 over 3 units square, guys. Okay, it should be units square. Okay, I accidentally wrote here units cube. Okay, should be units square. Okay, so this is your final answer. So I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Thank you everyone for your support, and I'll see you in the next video.